Hey everyone. So last week we talked about moisture. So just a brief review again. We looked at our trigger, and our trigger is in the 500 millibar chart. And here we go. So we have this trigger, this trough, that's going to trigger thunderstorms. We look at that. And then we looked at the instability. And the instability, we looked at that to know if thunderstorms are going to be explosive, they're going to be severe. And we found that there is a pretty good instability pocket in eastern Oklahoma on this day. And then after we looked at, well, will those storms last a long time? Will they be able to survive? So we looked at a dew point, and dew point is the moisture available. And we looked at this chart and we saw that, you know, around eastern Oklahoma, there's pretty good pockets of 70 dew points. So we know that there's going to be thunderstorms. We know that they're going to be most likely severe, and we know that they're going to last for a long time with this dew point, this moisture. So the next thing we're going to look at is, will those thunderstorms be supercell thunderstorms? Will there be tornadoes? So to look at that, we look at wind shear. And here, if we pull our shear, we have different parameters. So wind shear is basically the change in wind direction with height, and also the different wind speeds at different levels. So this video we're gonna get a little bit more details about that, because it's pretty complicated, but it's very important when forecasting for severe thunderstorms, and most importantly supercells and tornadoes. So we can look at our different heights in the atmosphere. Here they're depicted in millibars. We're actually going to look at this website because it's going to be more localized. So we would expect to have some wind shear in here. So if we pull our wind shear, here we have, sorry, I'm actually going to pull this website because it's easier. So here if we look at our 500 millibars again, so remember, this is up in the atmosphere. This is fairly high up, several kilometers up. We have, you know, we can see the depiction of the trough here, and we can see, you know, 70s, 80 knots up here, which we know there's pretty good forcing. We already know that, right, because of the trigger part of these videos. So let's look closer to the surface now, because that's what we care about really for tornadoes and supercells, right? So once these thunderstorms form, will there be wind shear? Will there be winds changing at different heights in the atmosphere in these areas to cause spin? So here we can look at 700 millibars. We can look at 800. We're getting close to the surface now, and 925 is very, very close to the surface. So we see nothing in 925 here, right? There's nothing going on. 850, oh, okay, you start to have a little bit of pockets up here. And up here you have pretty high, you know, 40 knots, 50 knots, because this is where the low is. If you remember from our moisture here, there's a low here, so we expect the highest amount of turning to be in this area. But we want to know about this area here. You know, and this chart is not very useful for us, you know, like, you know, why would you look at that? So if we want to know what's happening in the vertical component of the atmosphere in this area, then why not look at a vertical, right? So let's see this area where the highest instability. Let's click on it. So this is called a sounding. We talked about it very briefly earlier. So if you remember, for instability, you have this dotted line here, and this temperature profile, and between those are the cape, right? The amount of instability, and it's depicted here. So at the surface, at the mixed layer, most unstable, don't worry about those. So now we're interested about the winds. So you can see the winds here, they're all here, right? So when we talked about the 500 millibars, here we go, here's 500 millibars, that's, you know, 5-6 kilometers up in the atmosphere. You have 700 millibars, and you have 850 millibars. So if we look back at this chart, which was very annoying for our eyes, you can see that there's a lot of winds, 40, 50 knots here. So if we look at the vertical here, 500 millibars, we should be able to see that. Here we go. You have 10, 20, 30, 35 knots in this area. So you can see that this profile is coming. This is the surface up here. This is all surface. And this is way up there, the jet stream area, right? So we can see the winds are coming in from the south, and they keep going, and there's no real turning. There's really like a slight turning maybe. This profile is not great for tornadoes. For this reason, the analog generated a marginal tornado risk for this area. And if you want to look at it, you can also look at it with what's called a hodograph. So the hodograph is very complex, but you're looking at it from space, right? This you're looking at it from the ground, and you're looking upwards, right? So imagine a thunderstorm. This is your shape. This is a thunderstorm. It's tilted this way, like this, right? So there is shear to it because the thunderstorm is not straight up, right? If this thunderstorm was straight up, then the updraft of the storm and the downdraft of the storm would not be separated. And this is really important because here in this sounding, you see that the updraft goes into the storm and the downdraft goes on the backside. These are separated. This allows the storms to mature. This allows the storm to breathe, basically. If the updraft was going up and the downdraft was going in the same region, it would choke off the storm and you won't get anything. So here you have a nice tilted profile, which is, it's good for strong storms and etc. And there's probably going to be some supercell structures going on in this area. But your wind profiles are not the best for tornadoes. And let's pull other sounds in other areas. So maybe closer to the low, or sure, this area. Okay, here you can see it's a different area, so you'll have a different sounding, right? You can see that the winds are coming in from the south here, and there's way more turning, right? The winds are turning as they're going up. So they're going up, and they're turning, and they're actually increasing. You see this area here? That's 50 knots, 55 knots. Those are stronger winds in the mid-levels. Up here, there's a lot of cape. It's a nice tilted storm, and you actually have your measure of how fast the parcels are going up into the storm here, but we won't talk about that too much. It's updraft speed. So here you have a very nice profile, actually, of wind turning, which is called veering. The winds are veering with height. So this is pretty good shear up here. And if we look at the shear actual values, here you have shear surface to 1 kilometer, 22 knots, surface to 3 kilometers, 34 knots, which is pretty good. This is a pretty good profile for tornadoes. And your hodograph looks really good. It's a nice round storm. So this area would be good for tornadoes probably earlier in the day before it starts to be a mess. So if we look, this area, remember, we pulled the sounding right here, okay? This is just south of Oklahoma City. So now let's look at your risk. This is 4 p.m. Central Daylight Time. Let's look at our reflectivity, all right? For this area, 4 p.m. This is right here. We have a bunch of storms ongoing just to the western side of our sounding. So we know that this area, there's really good moisture, there's really good mixed layer instability, and now we know there's a really good shear in this area. So once these storms actually hit this area or form in this area, there are most likely going to be supercells, especially earlier on when they're isolated, and they're going to probably spin. There might be some tornadoes in here before they line up with the loss of diurnal heating and eventually die off in Arkansas. So if we were to do a forecast just based on these 4 parameters, we would expect eastern Oklahoma, probably up here too, and into Texas for some severe storms. And if you want to confirm your forecast, you can look at the Storm Prediction Center, and you can see that there is a slight risk. Okay, so they put out a slight risk for the area we're interested in. So they're forecasting for storms, rotating storms. So we can say that we did a pretty good job at forecasting. We're in line with the basically the finest meteorologists on the planet, Storm Prediction Center. Just based on 4 basic ingredients. We didn't look at this first. We looked at our 4 ingredients first. And just based on our 4 ingredients, we found that the 4 ingredients were matching up really good for eastern Oklahoma. And now what we do is we go chasing, right? We go chase. We probably target somewhere around Oklahoma City, maybe south or maybe southeast of Oklahoma City, and we will wait for storms and see what happens. And that comes to the luck part, right? If we were right or not. But basically, what you do is you use those 4 parameters. So you look at the trigger to see if there's going to be thunderstorms. You look at instability to know if these storms are going to blow up, and you look at dew point, moisture, to know if these storms are going to last for a long time. Are they going to sustain themselves? And you look at shear to know if these storms are going to rotate. Will the updraft be separated from the downdraft? And once you figure out where all these parameters are kind of coming together, you have a target area. And for this day, it'd be somewhere in this area where you have very good veering with height, and you have very good tilting of the storm up here. So this was kind of like our introduction. All these parameters, they're called M.I.S.T, and we talked about in different order. So M.I.S.T stands for moisture, instability, shear, and trigger. So if you remember that, and you practice yourself at looking at forecast models and pulling these ingredients, you're going to have a pretty good basis to severe weather forecasting. And we didn't talk about them in the M.I.S.T order, but it's a good way to remember M.I.S.T. We talked about trigger first, we talked about instability, and we talked about moisture, and then we talked about shear, because that's usually the order we look at it. It's not an exact formula. There's obviously a lot more that goes into these forecasting scenarios. There's a lot of things we could have talked differently. Fine tracks. But yeah, we can, the Storm Prediction Center is a very good website to kind of get used with the jargon of, like, they explain to you everything they're forecasting, what they expect. So this is a good way to get used to the terminology. And Environment Canada has their website where they put out maps and high pressures, low pressures. Obviously, we do that as well. We try to explain it the best we can. So we thought we would introduce this video series so people that are interested in forecasting for themselves, you can have kind of like a basis of this. And we kind of teach this in schools sometimes. So we teach this to kids, we teach this to adults. So I would recommend you look at these websites. They're all free, and you can get used to forecasting. And if you have any questions, just comment on this video, or you can go to our website. You can send us a personal message on our Facebook page. You can send us an email, ntpchasers.com. We'll be happy to answer any questions you have as far as we can talk about stuff. If you're interested too, if you made it this far into the video, we could do another video next week talking about certain types of mesoscale boundaries that can initiate thunderstorms when there isn't any trigger, right? So if you're from Manitoba, you know all about these that are called lake breeze. But you have different other boundaries. There's not just these huge troughs that are going to initiate thunderstorms. There's other little boundaries. It's more complex. We didn't talk about dry lines very much. Dry lines are very important. They cause some of the most damaging tornadoes in the United States. And the Rocky Mountains, another trigger in Alberta and down here. So we could talk about that next video if you want to. if you made it this far, just hit a comment saying yes, I'd be interested in that. If you have any ideas or anything like that, we'd love to continue talking about severe weather. We will also the format of this video. If you liked it, I know it's kind of hard because it's screen sharing, right? You can't really see us. We'd love to. Usually, what we do is we talk in schools with a blackboard, and it's more interactive. We'd love to do that, but it's really hard for us to do that from a computer. However, if you have any ideas, just hit the comments. Visit our websites. There's a lot of tools. Read our blog posts. Our blog posts, there's a bunch of forecasts in here. We get pretty basic, and we start off pretty basic, and we go pretty technical for other people that are more advanced. So, if you have any questions about any of our blogs, just ask us, and we'll explain to you what's happening. Yeah, if you have any, like I said, any comments, let us know. Thanks for watching, guys. This concludes the M.I.S.T portion of our videos, and hopefully we can make more of these little educational videos.